This is the first video that belongs to the valve preprocessing tutorial. In this video we will load the geometry and we will extract just the geometry parts that are necessary for the CFD simulation. It means just the parts that are in contact with fluid. Let's start activating the geometry module here and then click New. And the geometry module is active now. Now import the step file with the geometry of a valve. Click on File, Import, Step, and select this valves s.step file and click on Open. The warning appears. If you would like to take into the account units embedded in the file, click on Yes, and the geometry will be loaded. It's here, and now click on one of the principal views to quickly zoom the geometry. Now you can activate the interaction style switch to be able to rotate, zoom and move the geometry by mouse. The whole geometry is in one piece now. To process it, we would need to work with just smaller parts. So let's explode it into smaller parts. So go into the object browser here, select the globe valves S in the object browser, then go into the upper menu to New Entity, Explode, and from the subshapes type, select the type Shell and click Apply and Close. Now, as you can see in the object browser, the geometry is split into 29 parts, into 29 shells. Now select the parts that are necessary for CFD simulations. So it means just the parts that are in contact with the fluid. One of them is shell 10 in this case. So select the shell 10, click with the right mouse button, the menu appears, and click on Show Only. So, and this is the part that we will process further at the moment. This part needs to be exploded into smaller parts called faces. So let's explode it again to faces. So select the shell 10 in the object browser, click on New Entity, Explode, select the subshape type Face, and click on Apply and Close. Now it says there will be 255 faces after the explosion. To proceed it further, click on Explode. So, and now we don't need all the faces, so let's hide all the unnecessary ones. You can select them by mouse, and holding the Shift key enables the multiple selection. Once you select something, then you click with the right mouse button and the menu appears, and you can click on Hide, which hides all the selected faces. And again, select the unwanted faces, click with the right mouse button, and click on Hide. You should repeat these steps until you see just the faces of the original geometry that are in contact with the fluid. So, and that's it. This is the geometry for CFD simulation, just the inner part through which the fluid flows. And the last thing that should be done in this first video is to merge all the necessary faces together to create a shell. So at first, deactivate the interaction style switch to be able to select the whole visible geometry by mouse, and select the whole visible geometry. And now go into the upper menu, New Entity, Build, Shell, and here you can change the name of the shell you are going to create. So I will use the name region 12 dash first version and click apply and close. You can now check in the object browser that a new shell appears there. Now it's time to save the progress. Just press Ctrl S or go to the menu File and save your progress. For example, use the name part1.hdf.
This is the end of the first video. You can now continue with the second one.
Welcome in the second video that belongs to the valve preprocessing tutorial. In the previous video, we have prepared the main geometry of the valve. In this video, we will extract and simplify the geometry of the valve's plug. You can continue working in the previous Salome session, or you can start a fresh one and load the part1.hdf file we have saved at the end of the first video. I have started a new session, so I have to open the file from the first video. I will go to File, Open, and I will open the file part1.hdf. And now we have to activate the geometry module. Then we will go into the object browser and we will expand the geometry. Clicking on the eye icon, you can quickly show the geometry part. And here I will use the principal view to see the geometry. This is the geometry from the last video. But we will now process the geometry of the plug. So let's hide the processed CFD geometry of the valve. And let's expand the original geometry, globe valves S. Select all the shells. Right mouse button click. And click on Show Only. And this is the geometry of the whole valve. Now we can hide the shell 10 because we are done with the shell 10. And now let's go step by step and hide all the unnecessary shells from the original geometry, except the parts of the plug. Right mouse button click and click on Hide. And these are the only shells that we need for the further processing. Let's join them into one single compound to make the further work easier. Select them and go to the upper menu, New Entity, Build, Compound. Here you can change the name, but we can leave it here, this default one, and click Apply and Close. Now we will explode the compound into faces because we will not use them all, and we will do some geometry simplifications that will not affect the quality of the CFD results. So let's go to the upper menu, New Entity, Explode. Here in Subshapes Type combo box, select Face and click Apply and Close. And yes, we want 168 faces, so click Explode. And now select all the unnecessary faces and hide them. And now we are going to create a new face that will connect the lower and upper part of the plug. Let's start creating two new points on edges that should be connected with a new face. Go into the upper menu, New Entity, Basic, Point, and select the point on the lower ring of the plug and click Apply. The first point is created, so let's go for the second one. Switch the point construction to the point on edge. Select the upper ring edge and switch to point by coordinate. And set the coordinates for 0, 0, and 1. The new point will be here. And click Apply and Close. Now we have to build a line between these 2 points. So go to the New Entity, Basic, Line, and select these 2 points and click Apply. Now we will make a revolution of this line around the y-axis. So go to New Entity, Generation, Revolution. Select the line 1 as an object of revolution. And set the axis as a y-axis that you can find in the object browser on the top. It's this OY. Set the angle of revolution to 360 degrees and click Apply and Close. Now we will group all these visible faces into one shell. Select all the visible faces and go to New Entity, Build, Shell. Change the name of the shell, for example, to Region 3-Closed, and click Apply and Close. And now it's time to save the progress. Press Ctrl S and save the progress, for example, into file part2.hdf. And that's all from the second video. Welcome in the third video that belongs to the valve preprocessing tutorial. In the first video we have prepared the main geometry of the valve. In the second one we have prepared the geometry of the valve's plug. And in this video we will get back to the main valve geometry and we will split it into 2 parts, the inlet part and the outlet part. We will create an interface patch between inlet and outlet part on which we can later in the CFD simulation evaluate some interesting variables. We are also going to close the geometry. It means to create an inlet and outlet boundary faces and cut and remove the unnecessary part of the valve above the plug seal. You can continue working in the previous Salome session, or you can start a fresh session and load the part2.hdf file we have saved at the end of the second video. I have started a new session, so I have to open the file from the second video. So I will go to File, Open, and I will open the file part2.hdf. Now we have to activate the geometry module and expand the geometry in the object browser. Show the main geometry of the valve, the one we have processed in the first video. And also display the plug, the one we have processed in the second video. Now we can see the overlapping areas in the middle of the valve. Here we are going to split the geometry and make an interface. And also here, in the top, we are going to cut the part of the geometry that exceeds the plug seal. Now switch to the principal view and hide the valves geometry. Now show just faces of the valves geometry. So expand the valves geometry in the object browser, select all the faces, right mouse button click and click show. Let's make cuts now. Select the face we would like to cut. Go to Operations, Boolean, Cut. Optionally you can change the name of the new cut. As a main object, select the face we would like to cut. It's already selected. And as a tool object, select the plugs geometry. So it's the region 3 closed. Click Apply and do the same for the second face. So as a main object, select the second face. It's the face 158. And as a tool object, select the region 3 closed. That is already selected. It's the plugs geometry. And click Apply and Close. Now you can see here that new cuts were created. And now repeat the same procedure for the faces that are in the middle of the valves geometry. So select the face, go to the Operations, Boolean, Cut. Main object is the selected face. Tool object will be the plugs geometry. Click Apply. And the same for the second face in the middle. Select the face. It's a face 145. As a main object, as a tool object, select the plugs geometry, region 3 closed. Click Apply and Close. And two new cuts are here, the cut 3 and 4. As you can see here, some faces are missing here after the cutting. We can use missing faces from the plug. Expand the plug geometry, and the missing faces are face 2. So select face 2, right mouse button click, click Show, and the second one is face 123. So right mouse button click and click on Show. Now the geometry is complete. And now we have to explode cut 1 and cut 2 into faces and hide exceeding faces that we don't need anymore. So select the cut 1, click on New Entity, explode it into faces, and Apply and Close. And the cut 2, the same, New Entity, explode it to subshape type face, and click Apply and Close. Now select the exceeding faces and hide them. Now we are ready to split the geometry into two parts. Let's start creating the inlet part. So it means we have to select and hide the outlet part first. So let's do that. Select all the faces from the outlet part and hide it. So and that's it. This is the inlet part. So let's make a shell from visible faces. Select all visible faces and go to New Entity, Build, Shell, change the name to Region 1, for example, and click Apply and Close. So and this is our new shell, Region 1, the inlet part of the valve. Now, as we can see, there are holes in the geometry of the inlet part of the region 1. The hole near the inlet, in the upper part, and also there where we would like to have the interface. We have to close them, and to close the geometry we can use suppress holes functionality. So go to the upper menu, Repair, suppress holes, change the name, for example, to region 1 closed, mark remove all holes, and click apply and close. This is just the information that 3 faces were created in order to fill all the holes of the selected geometry. Click OK, and now you can see that all holes are filled by faces. There is the inlet face, the upper face, and also the interface face. And now we are done with the inlet part, and we can continue doing the same procedure to make the outlet part. So at first, hide the region 1 closed, and instead of it, show all the faces from the whole valve geometry. So select all the faces, right mouse button click, and click show. Now hide the faces in between the inlet part and the outlet part. Instead of them, show cut 3 and cut 4, and remove all the faces from the inlet part. This is the outlet part. So now we can create the shell for the outlet part. So select all the visible faces, go to New Entity, Build, Shell. Optionally, you can change the name, for example, to Region 2, and click Apply and Close. And this shell has to be closed as well as the inlet part. So let's do the same that we did for the inlet part. Select the Region 2, go to Repair, Suppress Holes, change the name, for example, to Region 2 Closed, mark Remove All Holes, and click Apply and Close. 2 faces were created to fill all holes, so click OK. And that's it. Now we have 2 independent shells, region 1 closed, that is the inlet part, and region 2 closed, that is the outlet part. So now it's time to save the progress. Press Ctrl S and save the progress, for example, into file part3.hdf. So, and that's all from the 3rd video. Welcome in the 4th video that belongs to the valve preprocessing tutorial. In the previous video, we have split the geometry of the valve into 2 parts, and we have closed the holes and made the geometry watertight. In this video, we will get back to the valve plug geometry, and we will make 3 positions of the plug. Open at 5, 8 and 11 millimeters. And we will create groups of faces on the geometry in order to prepare the boundaries, which we will use in CFD simulation afterwards. You can continue working in the previous Salome session, or you can start a fresh session and load the part3.hdf file we have saved at the end of the 3rd video. I have started a new session, so I have to open the file from the 3rd video. So I will go to File, Open, and I will open the file part3.hdf. Now we have to activate the geometry module and expand the geometry in the object browser. Let's start showing the geometry of the plug faces. Expand region 3 closed, select all the faces and show them. Now select 3 faces on the top of the geometry and hide them, because we will not going to use them anymore. Now let's make a shell from the visible faces. So select all the visible faces, go into the upper menu, New Entity, Build, Shell, its name could be, for example, plug to move, and click apply and close. And now we are ready to move the plug up for 5, 8 and 11 millimeters. In the upper menu, go into the Operations, Transformation, Translation. Set the name, for example, to plug-5 millimeters. Axis of plug displacement is y-axis, so set dy to 0.005, so it means 5 millimeters in meters, and click apply. Now change the dy displacement to 8 millimeters and change the name, for example, to plug-8 millimeters. And click apply. And the last translation, dy 11 millimeters, and change the plug name to the plug-11 millimeters, and click apply and close. And now we have 3 positions of the plug, 5, 8 and 11 millimeters. In the following, we will make groups of boundaries on the geometry of the inlet part, called region 1 closed, and the outlet part, called region 2 closed. We will select the inlet boundary, the outlet boundary, and the rest will be the wall boundary group on both inlet and outlet part. So let's start with region 1 closed, so it means with the inlet part, so select and show only region 1 closed. In the upper menu, select New Entity, Group, Create Group. Select a face group in the Shape Type option. And now we will start with the Region 1 Inlet, so change the name, for example, to Region 1 Inlet. Select the inlet face from Geometry. And click Add. The face 136 has been added to the list of faces which belongs to the group. So it's the only one, so we can now click Apply. And the inlet face group is created. So let's go on with the outlet face group. So at first change the name to Region 1 Outlet. Select the outlet face from Geometry, click Add. The face 2 has been added, and now click Apply. And the outlet face group is created. The last to create is the wall group, so change the name to Region 1 Wall. Click on Select All, and select the inlet and outlet face and click Remove. Now we have selected just the wall faces and we can click Apply and Close. The inlet part, Region 1, is divided into the groups now: Inlet Group, Outlet Group and Wall Group. We can check if it is correctly divided by showing only new groups. So select all the groups and click on Show Only. And now we can check if we have here all the faces that are necessary for further preprocessing. Seems good. So we can finish with the inlet part. Let's do the same for the outlet part, Region 2 Closed. Select and Show Only Region 2 Closed shell. And go into the upper menu, New Entity, Group, Create Group. Select the face group in the shape type option and change the name of the new group to region 2 inlet. Select the inlet face from the geometry and click Add. The face 80 has been added, so we can click on Apply. And the inlet face group is created. So let's go on with the outlet face group. Change the name to region 2 outlet. Select the outlet face from the geometry. Click Add. The face 2 has been added. And now click Apply. And the outlet face group is created. And the last to create is the wall group. So change the name to region 2 wall. Click Select All. And now select the outlet face and the inlet face and click on Remove. And now click Apply and Close, because we have now selected just the wall faces. So and now the inlet part is divided into 3 groups: inlet group, outlet group, and the wall group. So everything seems okay, so we can finish with the outlet part. So we have created 3 positions of the plug and groups of faces of the valve in this video. So now it's time to save the progress. So press Ctrl S and save the progress, for example, as part4.hdf, and press Save. So, and that's all from the 4th video. Welcome in the 5th video that belongs to the valve preprocessing tutorial. In the previous video, we have made 3 positions of the plug and divided geometry of the valve's body into groups of faces that we are going to use as boundaries in the CFD simulation later on. In this video, we will prepare a surface mesh, the triangular surface mesh, for all parts of the geometry, and we will export it in STL format that is readable by the OpenFOAM measures. You can continue working in the previous Salome session, or you can start a fresh session and load the part4.hdf file we have saved at the end of the previous video. I have started a new session, so I have to open the file from the 4th video. So I will click on Open, and I will open the part4.hdf. Now we can expand the geometry in the object browser. And now we have to activate the mesh module. There are 2 options how to activate it. The first one is by clicking on this icon, or the second one is selecting the mesh module in this combo box, like this. Let's start with meshing of the inlet part, called region 1 closed. Expand region 1 closed and select it. In the upper panel, click on Create Mesh, or alternatively, you can go into the upper menu to Mesh and click on Create Mesh. Change the name of the mesh, for example, to Region 1. Check if you are in 2D tab and select NetGen 1D 2D in the algorithm combo box. Click on the gear icon here and select NetGen 2D parameters. There is a name. You can leave here the default name, NetGen 2D parameters, or you can change it to anything you want. Change the maximum size. It is a maximum size of the triangle edge. So let's set it on 1 millimeter here. The minimum size is small enough, so we can keep it as it is. What I would always recommend is to set the fineness to very fine. And let's keep all other parameters unchanged. So click OK. And we are done with the mesh parameters for now, so click Apply and Close. Now we have to set the boundaries that would be made on groups of faces we have created in the previous video. To do so, select Region 1 Mesh in the object browser. Then go into the upper panel and click on this icon. Create submesh. Or alternatively, you can go into the upper menu, Mesh, and there is a Create Submesh as well. As a geometry here, you have to select Region 1 Inlet Face Group and change the submesh name, for example, to Region 1 Inlet. Now check if you are in 2D tab. Select NetGen 1D 2D as an algorithm and select NetGen 2D parameters as a hypothesis. We have prepared NetGen 2D parameters in the previous mesh setup, so there is no need to do it again. So that's all for the inlet face group, so click Apply. Let's continue with Region 1 Outlet Face Group. Select Region 1 Outlet Group as a geometry for the new submesh. Change the name as Region 1 Outlet. And all other parameters remain the same, so click Apply. And repeat the same for Wall Group. Select it as a geometry. Change the name to Region 1 Wall. And click Apply and Close. You can see the mesh in the object browser. There is the main mesh, Region 1. Then there are submeshes on face, Region 1 Inlet and Region 1 Outlet, and submeshes on compound, Region 1 Wall. So everything is ready for the surface mesh generation on the inlet part, on the Region 1. So select Region 1 Mesh here and click on this icon, the Compute Mesh, or alternatively you can find this Compute button in Mesh, Compute. So click on it. It will be meshing for a few seconds. And that's it. There is the mesh statistics, so we can close it for now. And here you can see the mesh on the inlet part, the surface mesh made from triangles. Now we will export the mesh as STL files. We will have 3 STLs, inlet, outlet and wall. Select Region 1 Inlet in the object browser. Go into the upper menu, File, Export, STL file. Optionally, you can here change the name and click on Save. And the same for Region 1 Outlet. Click on it in the object browser, go into the upper menu, File, Export, STL file, and click Save. And the last one, Region 1 Wall, File, Export, STL, Save. So we have meshed the inlet part of the valve, Region 1, and exported the mesh as STL. So now you should do completely the same procedure for the outlet part, Region 2. So create a mesh, create submeshes on groups of faces, compute the mesh, and export it. This is the mesh of both regions. Region 1, the inlet part, and Region 2, the outlet part. And all their STLs are exported now. And the last thing is to mesh the plug 5 mm, 8 mm, and 11 mm. It is much easier because plug is one part. It is not divided into groups. We should create just a general mesh, and we do not need to define any submeshes. So let's do that. Create a mesh. The geometry will be plug 5 mm. Change the name to plug 5 mm. As an algorithm, select the NetGen 1D 2D, and as a hypothesis, NetGen 2D parameters, and click Apply and Close. Now compute the mesh, close the statistics, and show only the mesh of the plug to see its mesh. Yeah, and now you can export the mesh as a STL. Click Yes, and click Save. And repeat the same for plug 8 and 11 mm. We have done everything that is necessary. We have now all the geometry meshed with the surface mesh, and we have exported it as STL files. Now we can save the progress, so press Ctrl S to save the progress, for example as part5.hdf. And that's all from the Valve preprocessing tutorial.